the standard model. In this video, we'll be covering the standard model, including the fundamental forces and the particles involved. Scientists have developed the theory of the standard model. This explains what the world is, what it's made up of, and how everything interacts together. It describes the fundamental forces and the fundamental particles in the universe. So when we're at school, we learn that atoms are the smallest thing. And as we progress in our science, we find that atoms are actually comprised of smaller particles. Now the standard model goes even further to describe the fundamental particles. And those are the ones that have no known substructure, meaning they're not comprised of anything else. They're the smallest particles. The fundamental particles are shown in this diagram. There are 6 quarks, and the different types of quarks are actually called flavors. So the flavors of quark are up, down, charm, strange, and top and bottom. There are 6 leptons, electron, muon, and tau, and then their associated neutrinos. There are 4 gauge bosons, and then you've got the Higgs boson here. So over the next few lessons, we'll look at what these particles are responsible for and what they do and how they interact. So this table shows the fermions. Those are the particles that are associated with matter. Quarks and leptons have many properties. However, the ones we'll be concerned about in this course will mainly be the charge of the particles. The standard model suggests there are 4 fundamental forces, and we've covered many of these in physics before. There's the electromagnetic force, the weak nuclear force, the strong nuclear force, and the gravitational force. The electromagnetic and gravitational force act over an infinite distance, whereas the weak and strong nuclear forces act over a very small limited distance. If the strong nuclear force was assigned a value of 1, the weak nuclear force is 1,000 times weaker. The electromagnetic force is less than 1% of the strong force, and the gravitational force is extremely weak, and scientists are still putting many hours of research into this. A little bit more information about the forces can be found here, especially the conditions of where they're present. Now, we've looked at action at a distance before, so this is often being described in terms of fields, for example, the electromagnetic field, where there is no contact between particles, however, there's forces acting on them. Now, the standard model suggests that the forces that exist are actually mediated by exchange particles. So particles are involved. When looking at electromagnetic forces, photons are the exchange particles, and this force exists when we have 2 charged particles. The weak nuclear force has the W and Z bosons as exchange particles, and it affects leptons. The strong nuclear force has gluons as exchange particles, and it affects quarks and hadrons. And the graviton is responsible for the gravitational force, and it affects all particles with mass. So when we're looking at electromagnetic forces, and there is a force of attraction or repulsion, this can be explained through the interaction of photons. So let's consider 2 electrons repelling each other. There's an electromagnetic force because we're talking about charged particles. Now, a photon emitted by 1 electron will cause that electron to recoil. And then when the other electron receives that photon, it will also feel that force in the opposite direction. This exchange is almost instantaneous, and the photons are not actually visible. They're called virtual photons. A similar thing occurs when we're looking at the weak nuclear force. This time, the exchange particles are the W and Z bosons, and with these we have 2 W type, so a positive and a negative, and the Z type has 0 charge. So the strong nuclear force explains why the nucleons in the nucleus of an atom are held together despite that strong electromagnetic force. The exchange particle in this case is called the gluon. Finally, the carrier of the gravitational force is called the graviton. It hasn't been discovered. This force acts over an infinite range, and it has an inverse square relationship with this range. List the 4 fundamental forces and the exchange particle for each.